In this podcast, we're going to learn a little bit more about the periodic table of the elements. These notes need to go on page 49 in your interactive notebook, and you need to make sure you put the date up at the top and leave room for a summary at the bottom, and do 2 columns, Cornell style. We've been talking about the periodic table for a while now, and just a couple of days, but I wanted to give a little bit more detail about how it's organized so that you can understand these different groups. This particular periodic table that I have here has 3 main groups that I'm going to talk about in this lesson. So we're going to talk about metals, which is this big blue group, and nonmetals, which is the pink group. And then we'll also talk about this group that's in between, which is known as the metalloids. To start with, we're going to talk about metals. Metals make up the majority of the periodic table. It's almost the whole table, in fact, and they have certain properties in common. I just wanted you to kind of look at all these different pictures of various metals found on the periodic table. Remember, these are naturally occurring elements because they're on the periodic table, most of them. And you might notice that they have some properties in common. They're all shiny. Most of them are kind of silvery looking, although not all of them are. And they're all solids. So as I said before, metals are found on the left side of the periodic table in this area here. That's kind of a light blue color. And they make up about 3/4 of known elements at this time. So I'd like to now talk about some common properties of metals. First of all, number 1, all metals are silvery, or most are sort of silvery, and all have a high luster. That is, they are shiny. So you can see here sodium, which we've talked about before, and potassium. Mercury is a rare metal in that it is a liquid, but you can see iron here, lead, silver, gold. They all have luster. The second property of metals is that all metals are ductile and malleable. And I don't know if we've talked about these 2 terms before. It seems like we have, but in case you forgot, ductility, or being ductile, means that it has the property of being able to be stretched out into a wire, a thin wire. And malleability means it has the property of being able to be hammered into sheets. And because metals have ductility and malleability, or very ductile and very malleable, we use them to make wires, and we can pound them into sheets, even so thin that it's like paper, in other words, aluminum foil. And we can pound them into other kinds of shapes, like rings, other kinds of jewelry. The third property that I want to talk about with metals, third property of metals, is that they are good conductors of both electricity and of heat. So metals are useful for anything where we want heat to be conducted, such as pots and pans, and they're also useful for making electrical wires. So they're ductile, that means you can pull them into a wire, which is nice, but they also are good conductors of electricity, and so they're extremely useful for that. Another property of metals, I think this is number 4, is that nearly all of them are solid at room temperature, and they have a high melting point. So you have to heat them up quite a lot before they will melt, most of them, which is a useful property, of course. The one exception is mercury, which is pictured here. Mercury is a liquid at room temperature, but most metals are solid at room temperature. And of course, having that high melting point is extremely useful for making pots and pans, like I mentioned before. Imagine if we were using plastic to try and heat things up, you know that it has a much lower melting point. That would not be a good thing. The final property of metals that I wanted to talk about, I think this is number 5 actually, is that metals have a tendency to react in oxygen and react in acid as well. And so you see pictured here silver being tarnished in this spoon. We have rust, and then we have copper being corroded in oxygen. So copper, iron, and then this is silver, all react in oxygen. And there's a chemical change that occurs, so there's a color change and a texture change, as you can see in these pictures. That is a property of acids. Property of metals, that they react that way. Okay, so that was a discussion of the properties of metals, which make up this huge part of the periodic table. Now we're going to talk a bit about this group over here, the pink group, which are the nonmetals. Okay, so nonmetals make up the right side of the periodic table. There aren't as many of them by far as there are of the metals. It includes the far right two columns and then a few more. Carbon, nitrogen, oxygen, you can see those there. The other element that's considered a nonmetal but is actually on the left side of the periodic table is hydrogen, as you can see here. Hydrogen kind of sometimes acts like a metal, and it sometimes acts like a nonmetal, and so you will see it grouped with the nonmetals and sometimes grouped with the metals. Hydrogen's kind of unique that way. One of the properties of nonmetals is that they tend to form compounds with other elements and make these large compounds that are important in living things. So you can see here amino acids, water, and this, if you remember, this is glucose here, sugar. These are very important compounds in living things, and they're made up of mostly nonmetals. A second property of nonmetals is that they are mostly gases. Remember, metals were mostly solids, while nonmetals are mostly gases. So we can see here the red color indicates the gases, and you can see most of them are gases. The exceptions are carbon, phosphorus, sulfur, selenium, and iodine, which are solids, and then one of the only liquid elements at room temperature is bromine, which is a nonmetal. These two pictures are examples of some nonmetal gases. In this tube, in this tube is chlorine gas. That's what chlorine looks like all by itself. And then in these lighted signs, we call them neon signs. Well, the red color of the word sushi there actually is neon gas that's inside that tube, and it's being lit up. But when you see other colors, it's other of these gases. It's going to be one of the gases in this column, which is the noble gas column. And these are the gases that are used in these lighted signs. If it's the red-orange color like that, the word sushi, it actually is neon, but if it's other colors, it's going to be other gases. I think the green is krypton, but I'm not for sure. Another property of nonmetals is that the solid nonmetals tend to be colorful. They tend to be dull, that is, they're not shiny like metals are. And they tend to be brittle. You can't pound them into sheets and stretch them into wires. They're not ductile or malleable. If you tried to pound them or stretch them, they would just crumble into pieces. So here are some examples. We have carbon, iodine, sulfur, and phosphorus. And you can see that they're colorful and that they are brittle. You can see that they just have, some of them look like they're just powder. A final property of nonmetals that I wanted to mention is that they are poor conductors of heat and electricity, so they're kind of opposite from metals. Metals are good conductors of both of those things, but nonmetals are poor conductors of them, and so they are often used as insulators in electrical wire. So they're the part that keeps the electricity from flowing. It protects the wire inside. And they're also used as insulators of heat. So there's carbon insulation and other kinds of insulation. But nonmetals are typically used as part of heat insulation. We might use them to make an insulated cup or a thermos or something like that. Okay, I wanted to talk finally about the group that lies in between the metals and the nonmetals on the periodic table, and that's this group right in here. And they are a very special group of elements, not very many of them, but they're important, and they are called the metalloids. The metalloids include boron, silicon, germanium, and several others, and tellurium, and you can see what they look like by looking at these pictures. They look similar to metals in that they are shiny and silvery, but they have some different kinds of properties that are useful to us. What makes metalloids special is their properties that are in between metals and nonmetals. For instance, they're shiny, but they're brittle, so they can't be pulled into wires like metals can, but they're shiny like metals are. And what's really special about them is that they can act as a semiconductor. In other words, they can conduct electricity if it's a high temperature, but not at a low temperature. And it is this property that makes them useful in all of our electronic devices. So if you appreciate your MP3 player and your phone and your computer and your television and your, I don't know what other electronics you might be using, but they are all made possible because of metalloids, because they are able to sometimes conduct electricity and other times not, which means that they can transmit information. And it has been a complete revolution, the fact that we can make use of the metalloids in this way. Now, if you had to pick which one of these two elements was the metal and which one was the nonmetal, which one do you think is which? If you said this one was the nonmetal, you are right. And this one is the metal. So we can use properties to determine if something's a metal or a nonmetal. This shiny one is the metal, and this colorful liquid is the nonmetal. That's all I have for this lesson about the periodic table, and that's really all I need you to know about metals, nonmetals, and metalloids. And so I hope you guys have a great rest of your weekend, and we'll see you next week.
Made with Doodlecast Pro.